in the middle of this. Where this group originated from, it started organically off of LinkedIn. Andrew Ng asked people to share links to papers that are worth reading for people to catch up with what's cool and interesting in LLMs. And so we turned that thread into a reading group, and that's where we're at now. I've also started a nonprofit since called Human Feedback Foundation, all about human feedback and human input into AI. And so it's extremely fascinating. And I look forward to the presentation to hear how multilingual model AI is trained and fine-tuned, because that's a fantastic project and an example of how people can collaborate and create a whole new data set that is much, much needed, and put that in open source as a gift to humanity. So that's my 5 cents, and I'll drop more links into the chat. By all means, please use the chat to interact, ask questions. We'll get to as many of these as we can. And over to you, Joe and Marzieh, for the rest of the session.
Yeah, sure. Thanks. And hi, everyone. I'm Marzieh. I'm originally from Iran. I live in Amsterdam, and I have been with Cohere AI for a little more than a year now. My background, my PhD is on machine translation, NLP, and multilinguality has been really like a very close and dear to my heart, just because of like how diverse, like just in this room, like there are a lot of people from around the world, and how it's, once you speak more than one language, you realize how each language has its own nuances, and there are like concepts in a language that you cannot express. There are a lot of different aspects why it's important to work on multilingual problems. And in Aya, I think actually kind of similar to your reading group, was started as this kind of like organic getting people together and see what we can do from around the world project. So yeah, this goes. Around a year and a half ago, we started the Aya project. So we were looking at the community of people on Discord for the Cohere AI Discord, and just like seeing how people from all around the world, they really want to work on something, contribute to something, but there was like, we were thinking like, what would be a good, cool project that we can work, define and get everyone to work on. And we started this project with the humble goal of building a multilingual data set, depending on like, we see how many people can contribute, and then training a model on it. But very soon the scale of it was just huge, just because of how people were passionate about their own languages, and they wanted to preserve and contribute to their language representation in future models. So the end result has been really beyond our expectations. So we ended up collaborating with people from around the world, from 119 countries, building this data set that is just purely human annotated data set, is 200K, and as well as augmenting in various ways. We ended up having this 500 million Aya collection data set in more than 100 languages. And it has been great working with all of these people that are passionate about this project. So today I'm going to be talking about the effort and the result of the Aya data set and how we created that. And Ahmet is going to talk about the Aya model, then how we use this data set, as long as along with some other things to train this multilingual model. And there are just two of us here, well, three with Joe, but there are a lot of people behind this as well. So credit to all of our collaborators on both of these papers. Right, so I don't think I have to emphasize why multilingual language models are important, but I do want to mention that it's really crucial that we have seen in previous works that what goes into each of these, like if you want to work on multilingual data sets and models, you need some sort of human care and attention just because of how different these languages are. So it's not only a matter of, it is partially a matter of having like resources and data, but also really like people who would take care of a lot of things that otherwise might not be captured if we just use automatic translation methods to augment our data to have multilingual data sets. And the main goal of having this data set and multilingual model is that we can benefit from hopefully some cross-lingual transfer especially for languages that are not well represented in a lot of these models, as well as just in general for a lot of the languages, this would be the first time that they are represented in a model. So as I'm sure people here have been using ChatGPT and similar models, so the command models from Cohere, probably they start in English talking to them, and then you switch to your native language if it's not English. And it would be really nice if you can do all of the things that you do in English with these models with your language as well. So it's really important, and people have been working on this for, like, we are not really the first person to work on this. If you look at how just the pipeline of training a language model looks like, there is the pre-training phase, which you don't really need label data. So the size of the data that you can use in that stage can be then, as a result, just like huge. And adding multilingual data in that stage is also relatively easier because you don't need label data. So like, for instance, Wikipedia pages in all of the different languages can be used at the pre-training stage. But once you have this pre-trained model, then you want to instruction fine-tune this model to actually go beyond next word prediction learning to question answering type of and prompt completion type of tasks. And there you do need label data, and it's expensive, it's hard to get, and this has been where we focus for the AYA project. So we thought that we can, for the data part, contribute to the instruction type data in a multilingual setting. And when we say instructions, it's essentially pairs of questions and answers, or requests and completions, or responses. And there are a lot of things that we didn't really explore in this project. So there are also a lot of open questions and open research directions that we really hope, by also making these resources available online, that people can continue working on this in the future. So yeah, very quickly, like I said, there are previous works, really valuable works in this area, building multilingual models. And Ahmet will talk a lot more about the AYA model and how it was trained on. What I'm going to talk about mostly is about the data that we create for this project. This is essentially a big summary of what we did. So there are 3 components to the data that we collected in the end. First, we call it the AYA data set. Second is the AYA collection. And then third, at the bottom row, is the AYA evaluation suite. And it's a combination of manual curation and automatic augmentations. But we did want to have them also just like, not just like have one dump of data, because subsets of this whole collection can be used in different setups depending on the requirements. And yeah, here's a very just like summary of what this data set, how it compares both the data set and collection with existing multilingual instruction style data. And there are two things that I think I just want to bring your attention to. So one is licensing, which is very important. So really trying to, this was our one of our main goals. So trying to have an open license so people can use this data to train their own models, even in a commercial setting. And then second thing is the percentage of English in these data sets. And I think it's important because a lot of times we hear something is multilingual, but inherently there's this imbalance of data for different languages, and usually English is represented a lot more than others. And it is really important. So we really try to not have the same behavior in the AYA collection. So really trying to, because for English, we already have a lot of data sets, really trying to focus on non-English examples when we were building this data set. And it has been a huge community effort. So for the human annotation part, we built this UI. I don't know if anyone in the audience actually ended up using this. So for the past year, we ran this whole project, and people have been using this UI to contribute to the project. So the contribution looked in very just like summary in two different ways. So one was writing their own original examples, and second was we would show them existing examples either from the other users or from our augmentations, and then they would rate the quality, and then potentially if it's not really good quality, they would modify them, either the prompt or the completion, to make the quality acceptable. And it's really, especially like the first one, which is like a blank space, and people were writing their own examples. It was really important to capture the nuances of the languages. So whether it's just like recipes of food in a particular culture, or like information about literature or geography, like things that is very specific to that language and region and country, and you cannot really get that by translating like an existing Western focused data set from English to that language. So here's a summary of just like the distribution of people who expectedly a lot of our contributors were based in Asia. And also just like how the combination of different subsets that we had ended up building the AYA data set. And then the AYA collection, that was where we really thought, okay, so AYA dataset is really valuable, human curated, but the main bottleneck there is just scale. So you cannot, like everyone is contributing, but it's not going to be, the size of that is going to be limited because of how labor intensive it is. So in order to increase the scale of size, especially for a lot of languages that were underrepresented, we ended up doing different augmentations. And that included templating existing data sets to make them into this format of instruction and completion. And here you can see like a list of tasks. So there were like various tasks and objectives for these data sets. And then more importantly, from English, translating each of these data sets to all of our languages. So this was a cheap way of increasing the number of instances exponentially for a lot of languages that are underrepresented. So we ended up, here's like a list of data sets for different tasks. And yeah, we ended up generating more than 500 million examples for the AYA collection. And why this is important, because when you do this sort of automatic augmentation translations with the focus of preserving the balance for different languages, then you have a better, like a more equal ground for all of your languages. But once you are, if you compare that, if you rely on existing resources, so like for instance, here in this plot, you see the number of Wikipedia pages for different languages. then it's not expectedly. For some languages, there are a lot more. For some, there's a lot less. You have this imbalance. So we have this control in our augmentations that the blue bars are the number of instances we had in the end for the AYA collection, and it's more, much more balanced than the real world representation of different languages. And then lastly, it's very important, as Ahmed will also talk about, once you build multilingual models, to also evaluate and really understand how they do in different languages. So we preserved part of this data set that we collected in the AYA data set and released that as the evaluation suite, as well as just doing translations of a clean subset of DALI data set, and then doing post-editing on those translations to hopefully increase the quality for a selected number of languages that we had annotators for. So it's essentially in the end, like we have like a balance of high quality, relatively lower number of languages, like 6 or 7, and also like mid quality because it's automatically generated, but high coverage of languages in our evaluation suite. And that's the goal is that with using them all together, so all 3 subsets, you would get a good signal of how, if you are building a multilingual model, how you are doing in different languages and in total. And yeah, that's it for the data sets and collections that we built. And I'll pass it to Ahmed. I don't know if you want to share your slides, or I'm going to do next if you...
Okay, let's continue like this. Thanks, Marzieh, and thanks, everyone. Also, thanks for inviting us here. So I'm Ahmet. I'm a scientist, resource scientist at Cohere AI. I'm also from Turkey, living in Netherlands. So at home, I have to speak English, so it's quite multilingual environment. And I used to, I did my PhD like 1.5 years ago, finished. And my PhD topic also was about multilingual NLP broadly. That's a very brief introduction about myself. So actually, I will just continue where Marzieh left in terms of the AYA project in general. So in the project, our main target obviously was about the collecting a huge volume of data, collecting and building, creating. But also, of course, we wanted to showcase that this data is helpful, because this is the main point, right? If you collect the data, then you should be able to use it and show that that is really helpful for the model. This is where actually AYA model comes in. So we this is like a really brief kind of summary of the AYA model. So it's actually not only about the model itself, but it's about how to instruction tune, fine tune a multilingual model, and how to evaluate it together with the data mixture and evaluation mixture. This is the main gist of the AYA model. So I will give all the details about both fine-tuning and evaluation. Next slide, please. Thank you, Marzieh. So as I said, this important part is the data. And normally instruction fine-tuning is actually relatively straightforward kind of procedure, because you have a relatively strong large language model, then you have supervised fine-tuning data, instruction like formatted as instructions. And you don't need to normally have too many examples of such instruction, and you basically just fine-tune it. But unfortunately, for the multilingual models, when multiple languages, especially if it is scale of 100 languages, is in the model, then it's not that straightforward. That's our main point. So to be able to have such like a kind of good performance in terms of the instruction fine-tuning, we created kind of comprehensive fine-tuning mixture. This is built on AYA data, because this is, I mean, the main gist of the project. But we didn't stop there. We also added more data set to increase different aspects like a diversity, task coverage, and so on. So here we have multiple different class of data. One is of course like a AYA data, which is actually 2 different subparts. Translated data sets and also templated data sets. These are meaning just Marzieh, as mentioned, like template data set, we have the data set, then converted as instruction. And translated data sets, we kind of create a data set or take the data set in English, then translate it into multiple languages. This is the main, one of the main bulk of the data that we use. But together with that, we also use something called XP3X. This is still templated data. Instructions are created via templates, but in multilingual format. Also, we use something called data provenance collection here. This is a set of subset of, a collection of data sets that is permissively licensed so that it is completely valid to use. And after you use, you can permissively license the model or the data set that you use. But together with that, this is one of the interesting part that we use during the instruction tuning. We also create a synthetic data set, which we call it ShareGPT command. So this is, we use the prompts from ShareGPT data, which is normally actually built based on ChatGPT. So people prompt ChatGPT, get the completions and build as a data set. But we didn't want to use ChatGPT completions because of the license, potential license issues. So we use prompts, then pass-through command, Cohere command model, which is one of the state-of-the-art model at the time, which was, but the previous version of that. Then we had like a prompt and instruction format in English. Then we translated this data, all the languages as well, and built this instruction fine-tuning mixture that, as I said, covers 101 languages, very high volume, to more than 200 million examples, which is actually kind of impossible to use all of the examples during the fine-tuning. But it has a good task coverage, right? Because task coverage comes from most English data set, but also we have multiple multilingual data set that is translated. So it's really a large and comprehensive set of fine-tuning mixture. Next slide, please, Marzieh. Yeah, here actually we are kind of showing some statistics about the data. So more important point here is that actually the most high quality portion of the data is AI dataset. It is completely human created. But of course, the scale of this data is much smaller than other datasets. That was also another reason that we want to combine lots of different datasets so that we can still preserve some quality, but also increase the diversity. Diversity meaning here, both in terms of different tasks, but also in terms of different language grouping. Like we don't want to have a data that mostly represented in high resource languages, but we also want to have a dataset that also have a good representation of lower resource languages, which is maybe more than half of the 101 languages here. Yeah, let's go next slide. Thank you. So this is another thing that actually is pretty important for multilingual instruction tuning, because when you have such high number of languages and such high volume of data, how you balance the data or how you kind of sample, weighted sample the data during training is very important, because if you upsample the more English-oriented data sets, then potentially model will be really good instruction tune model in English, but not in other languages, right? But if you completely uniformly sample all the data set, then you will lose quite a bit degree of task diversity, because task diversity is mostly represented in English-oriented data sets. And one of the things that we kind of struggled throughout the project, but at the end we kind of achieved our goal, was this sampling. We actually had multiple kind of ablation to understand what sampling, what variation is better in terms of the balance. And what we end up, we call it translated data upweighting. So here we balance a little bit the data set in terms of languages, but we did not balance like uniform sampling. For example, English distribution naturally was 20%, decreased to around like 8%. And other language distribution increased from, let's say, 0.5% to 0.7%. So I'm guessing these numbers may not be precise, but this is more or less what we have, so that we slightly decrease the high resource language proportion, but we did not decrease too much to have this high quality task diversity. But we increase other language proportion a little bit so that we have more represented instruction mixture. This is also important in another way, because as I said, we had like 200 million examples, but we couldn't use all 200 examples during fine-tuning, right? So at the end, we use only 25 million examples, so that how you sample it is really, really important, because you never reach one epoch at the end, because it will be super costly and model will definitely overfit. Next slide, please. That was about the training. And of course, you should be able to measure, right, whether model is really performing or not. This is really, really important. I mean, regardless of multilingual instruction fine-tuning, this is, I think, the most important thing in LLM landscape now. And when it comes to multilingual instruction, multilingual models, I think evaluation is extremely tricky, because how to evaluate these multilingual models, in what languages, in what task, it is really, lots of people, lots of different labs is kind of researching on that, but there is no concrete like an answer. What we did, we tried to build some sort of holistic view in terms of models capability. Like, we want to include some task that is more discriminative nature, like a reasoning, let's say, but also we want to put some task in evaluation that kind of measure the general purpose language understanding. But also we want to see like an open-ended generation, because this is where these models kind of being useful for the people, right? If the model has really good discriminative performance, let's say, having a multiple choice questions and really good capability in terms of finding the answer, but if it's not really generative, it's not really able to generate answer for open-ended question, then it's not useful. So that's why we put all these different aspects of considerations and built an evaluation set. So this evaluation set at the end has 99 languages, has, as I said, different categories of tasks, like completely unseen discriminative tasks. These are zero shot, general purpose MMLU, but in multilingual way. Some in distribution generative tasks, these are like translation, summarization. These are important because this kind of give us the language coverage, like this 99 languages. Human evaluation for open-ended generations. Also, we use other LLMs to simulate this human evaluation. At the end, I won't cover much, but we also have a preliminary set of evaluation in terms of safety, because we wanted to see how model, I mean, how this depends how you define safety, but we looked at toxicity detection, harmfulness of the multilingual generations, also open-ended generation, and also gender bias in multilingual translation. So these are also set of kind of safety-oriented evaluation. Next slide, please. Yeah, so I won't give all the evaluation results because it's too much numbers and might be boring, but this is, I think, one of the most important evaluation in my mind of focusing the open-ended generations, because our baselines, most precisely like an MT0 or MT0X, those two models were actually pretty good in terms of discriminative performance, although our IA model was outperforming them. But in terms of the usefulness, we want to really see the open-ended generation. So how we evaluate open-ended generation, actually Marzieh briefly mentioned, we use the IA evaluation suite. So this suite has prompts, and we use prompts for multiple models, let's say IA and MT0, then get the generations for these two models and ask human or LLMs which model generation is better. That was how we evaluate those. And here you see the huge difference, because this is exactly why we were kind of focusing the data quality and focusing the instruction, multilingual instruction fine-tuning. In almost all the languages, I will come figure 5 at the end, but IA model has significant outperform the baselines, the main important baselines. So figure 5 is kind of interesting because the baseline model that we compare is Bacterian X, which is based on Llama 13B, which is like much more capable than our pre-trained model, which is MT5, but it is not multilingual enough. So that's why, except English, our IA model actually outperformed significantly. But in English, since it is Llama based and 13B, which is, as I said, is pretty strong, it was outperforming. This also kind of shows the direction and aim of our project. We actually did not really aim to build a strong English multilingual, strong English instruct model, but we want to build a multilingual instruct model. And this shows this asymmetry here. Next slide, please. Yeah, that was all about the model training and like evaluation and model performance. So very briefly, maybe 1 or 2 minutes, let's talk a little bit about limitation and potential like future venues. So I am aware of getting lots of questions. I hope me and Marzieh will have time for those questions, but let me do like the last 2 minutes for that, and then I think we can finish the presentation. So yeah, maybe you can continue all of them at the same time, Marzieh. It would be easier. Exactly. Nice. Thank you. So the main limitation it's kind of also showing in this last evaluation, the pre-trained base model that we use, which was MT5, which is still pretty strong. And more importantly, it has a 101 language coverage in its pre-training. But this is the main limitation. So because whatever you do in instruction fine-tuning time, it is always kind of constrained by the pre-trained model, pre-training phase. So that's why it's still, there is two way to go, like quite large way to go, because if you have a better multilingual pre-trained model, probably directly using IA dataset or the similar fine-tuning mixture, you may get much more performance. This is really, really important. But also language limit is there as well. So we did this project mostly focusing on this 101 languages, but these are not languages that, I mean, there are much more languages, right, spoken in the world. So this is also really important limitation. So we did not have much chance to focus on different dialects or code switching, but these are also important issues in multilingual NLP, because some, like, for example, in Netherlands, there are lots of Turkish people living, and there's like Turkish Dutch code switching pretty common. So we didn't even measure, actually, to be honest, how our model kind of perform in code switching scenarios. But this is something that definitely needs to be looked at. And evaluation, as I said, we tried to build a holistic view by combining lots of different tasks and multiple languages, but still not enough. I think there are more things to do in terms of multilingual evaluation, both in the resource side, but also like for example, human evaluation. We did a human evaluation, but only for 6 or 7 languages, I think. So that is another variant. So, but human evaluation, anyways, is extremely costly. So building a smart way to evaluate such models, their generation capabilities is quite important and very limited at the moment. Yeah, I think that's all about, yeah, maybe we can skip this because there are already lots of questions. That's all about our like a project. I think there are probably lots of things that we missed, but one last thing. So to showcase at the time how this data would be really capable with the much stronger model, we actually use the data fine-tuned stronger Cohere model and put inside this Cohere platform. You can see this, you can go this Cohere playground and pick the model called C4 AI IA. This doesn't support all 101 languages because of the pre-trained model, but it is limited with the 22 languages. But you can see actually model performance is pretty impressive in all these 22 languages. So just just in case if you want to check. Thank you.
That's great. That's great, Ahmet and Marzieh. Thank you so much. We can put the URL to that in the in our follow-up email, and also in the description of the video when we post it, the recording. Let's open it up for questions. Lots of things to talk about. Elena?
Yeah, my question, I mean, there's a lot of them in the chat, so thanks for giving me the first one. My question was about the paper that came out since AYA's release called UNIVAR, high-dimensional representation of human value distributions in multilingual LLMs. And they looked at 8 multilingual LLMs. So I'm very curious how the work on AYA could fit into that type of work where you can do modeling of human values and language, and use language models for that kind of work. How to see, you know, interesting things like how value distributions differ between different models. Do they have the same values in English and French? You know, do values in Indonesian and Arabic have any similarity? Very, very curious about your opinions on that. And if that's something you maybe have on your roadmap to look forward at, or just a response to that work.
Yeah, I can tell a very brief about this. So I was not aware of the work, but thank you for pointing out. I completely agree. This is extremely interesting. I mean, really, really interesting issue. And I would doubt that although they use lots of language models here, except ChatGPT, all other language models are pretty limited in terms of their multilingual coverage, actually. So it would be very interesting to see something like IA, potentially less strong in some languages, but more strong, relative, of course, in multiple other languages, like lower source languages, and see this. So we did not have exactly this direction of like a work, but we are actually kind of trying to understand in different contexts of this variation, like in RLHF, in terms of multilingual RLHF, how we can use multilingual feedback and how it actually impacts in different languages, but also red teaming, because it's very relevant context, like how we can do multilingual red teaming, which is extremely tricky because values or some like a representation of different harm in different languages would be extremely different. So we try to understand these angles. So we have multiple projects kind of running at the moment and trying to understand. And AI models, of course, has been used all in these projects.
How would I join or learn about these specific projects just really quickly?
I think these projects are kind of on the way now. So maybe we may share intermediate findings pretty soon. But yeah, since I don't even have a preliminary experiment yet, because more really experimentation and trying lots of ablations, all these are going at the moment.
No worries. Thank you.
I think it's important to emphasize too that, of course, the Cohere for AI community is open. It's an open community, so we can also circulate the application link for their Discord server. Amelie, wait, I just had it, and then it disappeared. There we go. Amelie asks, could you come back and talk about the topic about defining the weighting importance of the different data sources? Didn't understand how you determined which data mixture performs the best.
All right, that's a good point. So Marzieh, would that be possible to share again?
Yeah, I'm gonna share.
Yeah, that is a really good point, because there was more slides, but we kind of removed some of them to make the time more efficient. But yeah, of course, we don't have comparison for this. These different weightings. It's a bit up, I think.
Up.
I mean, I can tell. No need to show all this experimental result, but let's see the weightings for the bar plots. Oh yeah, that's also fine. That's one of the another one. But yeah, anyways, so the long story short is, so there we experimented with 3 different weightings. One, as I said, like translated, upweighting the translated data sets. So these are not translation data sets, but these are normal instruction fine-tuning data, but translated into multiple languages. So it's more upweighting more languages. That's the gist of that one. The other variant is called templated heavy. This templated heavy was mostly keeping the natural distribution. Like English was 20%, some higher source languages more than 2%, and lower source languages was much lower than translated heavy variant. And there was one last sampling variation, which was, we call it human annotation heavy. Here we actually kind of experimentally tried to upweight the IA dataset, which was much more smaller than all others, just to see the impact of this human annotated, human created data portion. So at the end, for almost all the tasks, except some of the discriminative tasks, translated heavy variant worked much better in large scale, I mean, in terms of the language coverage, because other like lower source languages represented much better than other variants. Also, since the translated datasets were more open-ended generation focused datasets, our model with the translated heavy variant works slightly bit better in terms of open-ended generations. And this was the main finding. But in terms of the human annotated, another interesting point was about human annotated heavy variant, which was the worst possible option, because the dataset was super small, the IA dataset itself. And as we sample it much more, actually dataset, this small IA dataset has been seen maybe 30 or 40 times throughout the training. Then, of course, model overfit this dataset, and this dataset was already skewed in terms of some languages. So that was the main reason it didn't work out that well. I think that's the main findings from this weighting ablations.
That's great. Quick question about, I know you mentioned this too in the chat. You know, in situations where states have at least 2 official languages. Canada, of course, has French and English, and New Brunswick has both of those languages as official languages as well. Can the data sets be used in contexts like that for translation, for raising awareness, things like that? Are they strong enough for that?
So you mean for like using the data set to train translation models in a like official governmental like capacity?
Right, right, yeah.
Yeah, I think it depends on the language in the end, like in terms of like just like quality is different per language. So like for something, I imagine for Canada with like English, French, it's probably not a bad idea. Uh, uh, but for some languages, it might actually be worse. I would definitely say that the if your sole purpose is to translate, maybe models that are like just like specifically translation models are actually more useful for that use case. And then the question would be, can we improve existing translation models with the data that we prepared? And depending on how you train your model, because our data is not, at least the AI data set is not parallel data, it's just in one language. But yeah, it can be used, I think, to improve translation models.
Great. Elena, any questions from you?
Yeah, there's a cool question from Ahmet I'm going to throw into the chat. What is the ability to add a new language or dialect to the IaaS model? And is there a recommended sample size for adequate accuracy on this new language dialect?
Yeah, that's a great question. So I know in terms of like adding new languages, you are at the mercy of, for more or less the languages that are presented in the pre-trained model. So if that language or dialect is not already there, it's not going to be also performing well with more data added at the fine-tuning stage. But in terms of, because you can switch your pre-trained model. So as we have like new multilingual models that are more powerful with higher coverage of languages, then those models can replace the MT5 model. But I think in terms of adequate size, what was your experience, Ahmed, with the languages that were already there?
So thanks for the question. Assuming that the language within the pre-training mixture, which meaning that we also use some instruction fine-tuning data, and especially if you want to use the model for only that language, I think data size might be relatively in the degree of thousands. Because then you want to shift the distribution into that particular language and you will fine-tune only for that language, then I don't know, 10,000, like a degree of 10,000 to let's say 200,000 samples might be pretty enough. Depends on the task as well. Like if it is very task specific, then it will be less, degree of 10 to 100. If it is more general purpose, it would be 100 to 200,000. So I assume it would be pretty enough.
Question from earlier on. Can you share or speak about the human hours that go into doing the human part of data curation? Just wanted to get an idea of the time it takes, the human time investment that you've been observing for annotation.
I don't think we have actually information about time exactly, but the project was up and running for, I think, 7 or 8 months, like fully, and we were just getting feedback from people and then modifying things in the UI. So it wasn't always like the same. So there were like some modifications, but it was essentially this user interface that was up on our website, and then people, depending on their time and availability, they would contribute there. For the and this was because of the open access nature, like anyone could participate. We did run some safety eval and just like red teaming and like probing the model to see how it is on sensitive and harmful examples. And for that, we used in-house annotators, because you need to, for this kind of like sensitive topics, you need to have some trainings as well as some support. So we didn't really, it's not responsible to just like ask anyone to go through examples like that. And for that, I know that it took like a few weeks of just red teaming the model, annotating these examples. But yeah, I don't have like exact hours for you.
I can chime in actually, as I was working on the French data set in particular, and it was coordinating volunteers and stuff. And the range is huge on how long it takes to, if you're just fixing a word or two in an existing prompt completion pairing. Of course, that's fundamentally different from if you're actually writing your own prompt completion pairings. And at first, it was taking me like 10 minutes to do one prompt completion pairing, right? So that would take me years, right, to get to the kind of 1,000 or 2,000 pairings that you need for the model to start to be responsive. So then I would like walk around my house and like talk into my iPhone in French, and then it would translate it, and then I would just edit it and post that. That also took a really long time. You know, so there's different levels depending on which different task, but it's an enormous amount of work. And one thing we did is worked with high school students who were, of course, in Ontario and in many other places around the world. They have to do their 40 hours of community service for a not-for-profit, like Cohere AI is a not-for-profit, doing some sort of volunteering. So instead of something boring like picking up trash or you know, making coffee for somebody at a large not-for-profit, they were able to get their hands into this and use their skills in language and see how that affects a project like this in machine learning. So, you know, then we had people go into retirement homes. We had people do this with their families. The motivations for people to participate was very much around the equality of access and social justice, rather than you know, to see to see this in the market. It was basically to see what people could do with it, and to see if we could make a model work in their language. Some of these languages had never ever been included in any data sets, like Malagasy in Madagascar. Let me throw to Sergey. I think you can unmute yourself now, Sergey, actually. I think.
Oh, okay. Thank you guys for the very interesting presentation. My question is about the instruction fine-tuning process. I put a longer version of my question in the chat here, but I'll just kind of try to rephrase it briefly. So when a human answers a request or an instruction, there are different ways to answer it, and especially if it's an open-ended request rather than just a factual question that has one correct answer. Of course, when we interact with language models, a lot of our requests are open-ended, sorry. There are different things that influence the type of request, the type of answer that the person will come up with, language, of course, is one of them, but such things as the personality type of the person answering, and their emotional state, and the situation they're in, and the type of relationship they have with the person asking the question. Those things will influence the type of response. And now, if suppose you have a question asked or a request asking two different languages, and suppose the request is basically the same, just a translation of the same request in another language, and suppose it's addressed to two different people, and each person is fluent in the language of that request, and suppose those two people are equally knowledgeable and equally intelligent and educated and qualified to answer that question, but they are they differ in terms of personality types, they differ in terms of their emotional state at the moment, they differ in terms of what situation they're in. Will the language still be the bigger factor in influencing what type of response they will come up with, as opposed to those other factors? Thank you.
Can I just jump in and there we go. I can jump in a little bit here before Ahmet and Marzieh. But of course, my work is in linguistic anthropology, which is predicated on that very idea. And I think it's true that there is the language people use and the content of that language and the kind of pragmatics of how they deliver it are inseparable, right? What we're doing in machine translation and machine learning and with large language models is artificially separating the kind of semantic content of language from the person in the context. And so no, I agree with you and would say even further that not only does it influence, it's inseparable. So in a sense, we're kind of artificially simplifying the process of language in order so that we can do kind of easier downstream stuff. I think the practical answer to that question is through volume. If you can get repeated, so for instance, and Marzieh, maybe you can talk a bit about this, but of course, but the way we set up the Aya interface was to get multiple people to agree that yes, this is a good answer to this prompt. So if you can get agreement, right, from 2 or 4 or like 10 people that yeah, that's good, or, yes, that's appropriate. Sure, they might say things in slightly different ways. There might be regional differences or personal differences or emotional differences, but there's a general consensus that they have captured the spirit of the question. And I think that's really the only way of doing that kind of thing is through getting people to check each other's work, essentially.
I think that works for closed-ended questions. For open-ended questions, because there's no correct answer, especially if it's something that calls for a creative response. There are very many different ways to answer a question creatively, and people will not agree on which of these is the best response.
Yeah, and I think it's, I mean, they are open-ended insofar as that they are that they don't just have a one-word answer, but they're closed insofar as that the answer's got to fit in the box, right? So the question is, how can we respond in a way that would be most useful and fits in the box, right? It's a constraint set up by the system, right? So so even if they're open-ended questions, as annotators, we close them, right? We close them and cap them. Otherwise, there's no utility to it in the kind of utility people want from a conversational interface. Marzieh, Ahmet?
Yeah, my answer kind of reductionist, but first of all, I completely agree. That's like the reason that I was saying evaluation of these large language models, regardless of the multilinguality, is extremely tricky because of this very reason. Like how do you evaluate a creative answer is really something we're still working on that, like a lot of LLM people researching on that. When it's more creative, like because this is actually integrated into the model, right? You can sample, there is something called temperature, for example. You can increase the the you can try to get a more variant answer from the model, but how to evaluate it is extremely tricky. So one of the way to do this is you try to ask person that are evaluating is lots of different aspects like factuality, creativeness, and fluency. I don't know, like red teaming. So you ask such a question that the answer should cover all of them in the best way. But this is also very tricky, right? Even for a human. So that's why I don't have an answer. But in terms of the, I also kind of follow what has been said here, because I mean, here is more like a practical point. We need to take a practical path to understand and evaluate these models, right? Okay, this is a question. These are 2 or 3 answers. Which answer follow the instruction better in terms of this, and this? So I think this is, at least for now, is the most smartest way to do it. But it is extremely limited. I completely agree with that.
Thank you. That was a really good answer. And I am here to wrap things up now. As fun as it's been, it's a fantastic session. I could keep asking questions about this one all day long, about the design of it, the outputs of it, what you've been seeing since then, and how people have used it. An example of that would be amazing. What you would have done differently. I mean, we could just go on for another hour easily. Thank you very much for doing this work. Thank you very much for coming and sharing what you've done with us. Loved having you all for this session, and thanks everyone for joining us. Please take a look at the schedule for upcoming sessions. I'm just going to drop it quickly in the chat and have Joe say a few more words, and then we will wrap up. Thank you.
Yeah, not much more to add. If you want to keep chatting, if you're in Toronto, we have a AI pub night. Next one is on April 30th at Waylands Gate, where we meet and argue about things AI related, or I do anyway, and everybody gets mad at me. But yeah, thanks, Marzieh. Ahmet, good to see you both again, and looking forward to see what happens with the Cohere for AI community and with the model in particular. Thanks, everybody. Have a wonderful day.
Thanks for having us, and thanks for the great question. It was a lovely audience. Yeah. Have a good day.
Thanks very much, and thanks all of you. Bye-bye.
Thank you. Thanks, Ahmet. Bye-bye.